Guys, so we are back here for week 2 of distance learning. So this lesson today is just going to be focused on geometry and some of the more basic geometry concepts that you need to know. The hope is that you already know a decent amount of these, or you've at least heard of them. So a lot of this should just kind of be reviewing some stuff, maybe introducing a couple new topics, but for the most part, you should definitely have seen a lot of this. So first thing, what is geometry? What is the definition of it? It's the study of points, lines, and planes in space. Now, before we kind of continue on, I'm going to ask that you guys pause the video and I'm going to zoom out a little bit to make sure you can see all of the definitions. I want you to pause the video, copy all of these definitions down, and then we'll join back in. Once you're done, you'll just hit play again, and we'll go through what the notation is and what a diagram looks like. Okay? Okay, so hopefully now you have pressed play again and you are ready to start going over the notation and the diagrams for all of these. So starting with a point, the simplest figure in geometry, has no size and no dimension. The diagram for that, we're just going to use a dot and then it would be labeled with a letter. So in this case, if it's an A, our notation would be point A. Okay. Although we use a point to kind of identify it, again, like its definition, it really does not actually take up any size, takes up no space, and doesn't have any dimension. Now we have a line, an infinite set of points that extend in two directions. The line looks exactly what you think it would. It has the two arrows at the end to make sure you know it goes on forever, and it would have 2 points on there identified with letters. That way you would know what to be able to call it. So in this case, it would be line AB. You write your letters, and then you just draw almost a miniature line above them. The notations that we're talking about here today are very important because if you didn't put that line above the letters A and B, people wouldn't know. Are you talking about a line, a segment, a ray, things like that? You need to make sure that you are being very specific. Now we have an endpoint, and an endpoint, it can look a lot of different ways, but a very common one might be right here, right? I labeled this point right there A. We would just write that as endpoint A. Right? And that's where the line stops, the point where we see a line stopping. Then we have a ray, part of a line with one endpoint and continues on forever in one direction. So it's going to start with an endpoint, and then in the other direction, it's going to go on forever. Let's say that endpoint is A, the second one is B. You would need to make sure the order you write this in is accurate. You always want to start with your endpoint. So this would be ray AB, and you would draw a little ray above it. Okay, notice the difference between line and ray. The line had the line above it, the ray has a little arrow like a ray above it. You need to make sure you're being specific with your notation. Then we have a line segment, part of a line with 2 endpoints. This does not matter now if you did A or B first. So A, B, I'll just keep it going left to right, and you would just draw a little bar over it because it's almost as if having a segment above it. Next one is a plane. It's a flat surface that contains lines and points and extends on forever. Now, when we draw a plane, we don't draw it taking up all the space because obviously you wouldn't be able to draw a plane that goes on forever. Right? But this is pretty much just saying, imagine if you had a piece of paper in front of you, but it extended on forever in all 4 directions. Okay? It went out in all ways, and it was just one large piece of paper that extended on forever. That's pretty much what a plane is. Okay, and you're going to have those marked by a letter in one of the bottom corners normally. Sometimes it can be the top. A lot of the times, though, I think you do see it in the bottom. And you would just label that plane A. It would just be labeled plane A, or whatever letter it might be. Last one is an angle. 2 rays that meet at a common endpoint called the vertex. So we have 2 rays. It has a common endpoint. That endpoint's called the vertex. So maybe I would have a point here that was A, B, and C. When I go to write what my angle would look like, you always have this little kind of less than arrow, okay, that represents your angle. It could be angle A, B, C. It could be angle C, B, A, or it could be angle B. And what I want to point out about that is if you notice, your vertex, that endpoint in the middle where they meet, is always going to be in the middle if you're using all 3 points to talk about your angle, or it'll be the only letter you use if you're referring to the angle by just that letter. But it's a vertex that's always going to be in the middle. That's the one that it works all around. Okay, So let's get on to some examples. We're going to use correct notation to name the following. So we're going to name 3 points. So I could have point J. I have that point right there. I have point L. And I have point K. All 3 of those are points in this diagram. 2 lines that I have. If I wanted to name 2 lines, I have line JL, right? That's this line right here that I just did in purple. And I have line KL, which is this line that I'm doing in blue. And then it says name a plane. This entire drawing here, let me make that green a little easier to see, is a plane, and it's labeled with the letter P in the bottom. So this would be plane P. Okay? Now numbers 4 through 6, it says use correct notation to name the following. Again, 2 segments and their lengths. So when we go ahead and name 2 segments, the first segment I can do is segment MP. That segment is equal to 4 centimeters. It's labeled right there for you to see. Then I also have segment PN. Notice I'm just doing the segment bar above it, and that's equal to 6 centimeters. It's given to us right there. Now it wants to know 2 rays. The one ray I have is ray PM, and the other one is PN. If you notice, it has to start at point P because that is the end point for both of those rays, and that's always what needs, the first letter always needs to be your end point when you're talking about rays. And then it says give one angle and its measure. There's a couple different ways that you could write that. You could write it as angle P, you could write it as angle MPN, or you could go the opposite way, NPM. But regardless, if you notice, that angle measure is 80 degrees. Now, when you're writing this, when you're actually giving an angle measure, you want to put an M in front. So it would be the measure of angle P, or the measure of that angle. You always want to put an M in front because those all mean the measure of the angle. So whenever you're giving an actual number, what the actual measure is, you need to have that M in front. If you're just naming an angle, you don't need to worry about that M. Okay, so now that we have done those, we're going to move on to looking at angle and line relationships. So starting us off, first thing, it says the unit in which angles are measured is called degrees. And I think for the most part, we all knew that, but that's just kind of a reminder, and that's what that little circle is next to the number. That's what the degree symbol is. So we have 4 different types of angles that we're going to be talking about. The first one is an acute angle, and that's an angle whose measure is between 0 degrees and 90 degrees. It's not going to be 90, it's just up to that number. Okay? Then we have an obtuse angle. An obtuse angle is an angle whose measure is between 90 degrees and 180. Again, it's not including 90 or 180, it's anything in between there. Then we have a right angle. That's an angle whose measure is exactly 90 degrees. You'll know that because you'll see this box in the corner. Okay, that box in the bottom where the vertex is, that tells you it's a 90-degree angle when you have that square there. Last one is a straight angle, and that's an angle whose measure is 180 degrees. Okay, it's going to be a straight line, so all the way across is 180 degrees. Now we have the vertex, and again, that's where we had already kind of mentioned this up above, but I'll say it again. This is the end point where the 2 rays meet to form an angle. So the vertex in this case is that point right there. That's going to be important because we're going to be referring to the vertex a lot when you're talking about angles. Then perpendicular lines, that is 2 lines that intersect to form 90-degree angles. And again, you would know that because you'll see that box in the corner there. That tells you that it's a 90-degree angle. And since 2 lines are meeting at that, you know that they are perpendicular lines. Next two types of angles that we're talking about, and again, hopefully a lot of this is review for you guys, are complementary angles. Complementary angles are two angles that sum to 90 degrees. If I took 30 degrees and 60 and I added them together, it would give me 90 degrees. It forms a right angle, so they're complementary. Supplementary angles are two angles that sum to 180 degrees. If I added up the two angles, it would form a straight line. 120 plus 60 would give me 180, so I know that those are supplementary angles. So now let's do some practice problems. Tell whether the two angles that are given with the given measures are complementary, supplementary, or neither. So let's look at these ones, 53 and 37. If I add those up, 53 plus 37. 3 plus 7 is 10, 0, bring the 1 up top. 1 plus 5 plus 3 is 9. They equal 90 degrees, so they are complementary angles. Now let's look at number 2. We have 106 plus 84. 6 plus 4 is 10. 0, bring the 1 up top. That's a 9. Bring the 1 down. 190 degrees. That's going to be neither of them. To be supplementary, it had to be 180 degrees. Next two problems say find the value of x for each pair of complementary or supplementary angles. So looking at this first problem, I see that there's the right angle. So that means I know that they are going to be complementary. They'll add up to 90. So 71 plus x has to equal 90. So I need to figure out what x is. I can subtract 71 from both sides. So x would give me 19 degrees. That's what the measure of that angle would have to be in order to make this a complementary angle. Now this next one you can see is clearly a straight line, which means they're going to be supplementary angles. So that 113 degree angle that we're given plus the x angle has to equal 180. I can go ahead and subtract 113 from both sides. So then we would be left with x is equal to 67 degrees. Okay, so now let's keep going. So now we have vertical angles. Those are angles that are formed when two lines intersect. Okay, and intersect just means that they cross each other. Vertical angles are always equal. They are always going to be equal to each other. So angle 1 and angle 3, those are examples of vertical angles because they are opposite from each other, as well as angle 4 and angle 2. Okay, vertical angles are the exact, they are completely across or opposite of each other. 1 and 3 are across from each other, 4 and 2 are across from each other, so they're always going to be equal. So let's look at some examples. In the figure below, if the measure of angle 1 is 125 degrees, give each of the other angle measures. So angle 1 is 125 degrees. Right? That automatically means I know that angle 3 is also going to be 125 degrees because they're vertical angles. Now to figure out what 2 and 4 are going to be, if you notice, and you can do this either way, it doesn't matter, but that's a straight line, which means angles 1 and 4 have to add up to 180 degrees. So 125 plus, we can say angle 4 is x, would have to be equal to 180 because they are supplementary angles. I can subtract 125 from both sides, so that means x is equal to 55 degrees. So the measure of angle 4 is 55 degrees. If angles 4 and 2 are vertical angles, that means the measure of angle 2 would also have to be 55 degrees. Okay? Last couple problems we are going to look at, finding the unknown angle measures. So we're going to classify the angles as complementary, supplementary, or vertical, and then make an equation to find the value of x. So this video is actually about to end, so I'm going to go ahead and pause here. The video of us finishing these next three problems is going to be posted right below. So you can stop this one and then pick up right with the next one.